Welcome to Unit 2, Lesson 12, Polynomial Division 1, Practice Problems. Okay, so let's get into it. All right. The polynomial has a known factor of x minus 4. Rewrite p of x as the product of linear factors. Okay, I did the math already. X squared times x gives me x cubed. That was hard to see. And I ran through it. My answer is up here. So now, I have x minus 4. That's the factor we were given, which goes right there. And then x squared plus 1x minus 6. The numbers that multiply to 6 are 1 and 6 and 3 and 2. 3 and 2 have a difference of 1. So that lets me know that x plus 3 and x minus 2 are my factors. Okay, now sketch a graph of the function. This is a positive x cubed. It starts low, it ends high. I got a 0 at plus 4, at minus 3, and at plus 2. And then if I multiply my y-intercept is 24. So I'm going to come up. I'm going to come down through 24. I'm going to come around and go back up. It's going to look something like that. Okay, Tyler thinks he knows one of the linear factors after finding p of 1 of 0. So that means that x is equal to 1. That's the intercept. That tells us when we subtract 1 from both sides, x minus 1 is a factor. Remember, when you have an intercept, you have to change the sign and make it a factor. Okay, so Tyler made a mistake. Our factor is x minus 1. He wrote positive 1. So if we write a negative 1 here, our signs change. And then when we add on the diagonals, we should get our original term back. So x squared times x is x cubed. Negative x squared times negative 1 is negative 1x squared. Now, what adds to make negative 9? Negative 8 times x is negative 8x squared. Minus 1 is negative 9x. So get x cubed minus 9x squared. All right. Negative 8 times negative 1 is positive 8x. Negative 15 times x is negative 15x. So what went wrong? This needs to be positive. Positive. This gives us plus 23x. And then 15 times negative 1 is negative 15. So this sign had to change right here. So back to negative 15. Okay, so be careful with your signs. Okay, when you take a standardized test, you won't have time to divide all this out. This is x to the 4th. You're going to have 4 linear factors. Okay, let me show you a shortcut. So we know x minus 2 is a factor, okay? And x plus 1. So all of them have x minus 2 and x plus 1. You just got to figure out the other two. But you don't. What you're going to do is put this into the calculator into y equals. You're going to put y equals, put your original function in a calculator. We know our intercept is x equals 2 because to go from a factor to a intercept, you switch the signs, and x equals negative 1. That should give you 0 on the calculator. Now, all you have to do is set the rest of them equal to 0 and get your intercepts. So, x plus 1, that's multiplicity. If you graph it, you shouldn't see multiplicity. But let's try 2x minus 5 equals 0. So add 5, 2x equals 5, x equals 5 over 2. Put 5 over 2 into the calculator. Now, to get halves, you want to change 5 over 2 equals 2.5. So you're going to go window, hit the window button, change your delta table to 0.5 to 0.5, and that'll get you to 2.5 on X. Go back and hit graph again. Second, then graph to bring up a table of values, and you will see that 2X minus 5 won't work. So now we're going to try 2X plus 3 is equal to 0. Subtract 3, 2X is equal to negative 3. Divide by 2, X is equal to negative 3 halves. Hit the up arrow, go to negative 3 over 2 or negative 1.5. If this equals 0, then B is the correct answer. Okay, so with standardized tests, you got to kind of play with the answers and see which works. Okay, so we did this one a long time ago. So now, making this neater. Sorry about that. Sorry for giving you vertigo. All right, now here's our X. 1 plus R, that's X. 1 year, 300 is the start of the next at the following year. So we got 3 years going on. So now 1,000 was deposited first. That grew over 3 years. 300 was deposited second. That only grew over 2 years. And 500 was deposited last. So that only grew over 1 year. And now, if the interest rate is to the nearest 4%, 4%, percent, the word percent literally means divide by 100. So 4 divided by 100 is 0.04. So what you do is put this into the calculator. 1,000 times 1.04, because it's 1 plus R is in our problem, plus cube, I forgot to cube it, 300, 1.04 squared, plus 500 times 1.04. Put it in the calculator just like it's written. Just like it's written. And you should come out to 1969.34. Okay, state the degree in behavior. So I'm looking for the highest X. So it doesn't matter. They should be written in proper order, but this one is not. I got positive X cubed. What positive X cubed does is start low and ends high. My constant, my number within an X is positive 5. I don't need to worry about my zeros because we just want the degree in behavior. So as X goes to positive infinity, f of X goes to positive infinity. As X goes to negative infinity, f of X goes to negative infinity. Oh, so I put it in the end that the degree is 3 and the constant is positive 5. In behavior, find the highest coefficient. The end behavior is negative 2x to the 5th. It starts high, it ends low. So the graph is going to look like that. So as X goes to positive infinity, f of X goes to negative infinity. As X goes to negative infinity, f of X goes to positive infinity. Okay, what are the points of intersection between the graphs of the functions? So many of you opted to put these into the calculator, but let's do it the algebraic way. So we have to set these equal to one another. So what I'm going to do is turn them back into trinomials. I'm going to multiply these binomials. X squared, 3 minus 1 is 2, plus 2x. 3 times negative 1 is negative 3, equal to x squared minus 3x minus 3. Okay, so I subtract x squared from both sides. I add 3x to both sides. I add 3 to both sides. Set them equal. That cancels. That cancels. That cancels. I get 0. I get 5x. 0 equals 0. 5x equals 0, so x equals 0. So the point of intersection is only at 0. 3 times negative 1 is negative 3. 1 times negative 3 is negative 3. So the point of intersection is 0, negative 3. And I'm sure if you graph these, you will see where your point of intersection, you should have one point of intersection.